Okay, let's get started. We do have Nick Wagner on the line. He is the Director of Sharding Product Management. Um, he and I will go over some questions that you may have for us, and then see if you need more information. We can go over some of the slides to clarify your questions. Right. Do you have any questions, Judith? Okay, good. Judith has sent a message on the chat. Basically, they're looking for understanding the topic as a developer. Certainly, we can touch base these slides and see it from a developer perspective. What does it provide, and how one would access the sharded database from the development standpoint of view. Okay, so I'll go over some of the slides and I'll touch base on the APIs that you would need as part of accessing the database. Okay. All right. So I do have a few slides here. Sharding overview, which talks about the technology itself, the concepts, the benefits, and the use cases. And then I do have some slides that talk about how do you deploy a sharded database, how do you create a sharded schema, and then how routing happens when you access a sharded database. Okay, so we'll cover these topics. Right. What sharding is, it's basically a geo-distributed database architecture that allows you to get linear scalability, fault isolation, and global data distribution. Okay. What it entails is it entails horizontal partitioning of data across a pool of databases. We say up to 1,000 databases in this first release, right? And these databases are hosted on typical physical servers, or even for that matter, virtual servers, which have their own resources. There's no clusterware, there's no shared storage for these shards, right? And the data is distributed across all these shards based on the key that you get to specify when you design your sharded database. Okay. The advantages, as I mentioned, linear scalability. For your workload and concurrency and transactional aspects, you can start with few nodes, and if you want to increase your metrics, then you could simply add shards to the pool and you get linear scalability. Extreme availability: if one of these shards goes down, all the other shards are available for business. Only that one shard will be undergoing a brownout, right? So that's extreme availability. And then global data distribution, wherein you can have data closer to your consumers, to your users, or you can honor your data privacy regulations, making sure that certain shards will decide only in their country. For example, German data in German data center, American data in American data center, so on and so forth. Right? And you get that capability with shard. Quick overview on the components of a sharded database. You have a bunch of shards which host the data as well as the replicas. You have shard management and routing tier, which has the two components in this: shard directors, which are instrumental in routing the connections. That's one. And then also the catalog database, which hosts the metadata of a sharded database, hosts the goal schema of your application, and many others, which we'll talk about in a bit. And then above, you have the connection pools, which will use the sharding APIs. Basically, we have new APIs that you would use to specify the sharding key so that you can get routed to the right shard, which has data pertinent to that particular key. Okay, so quick capability list. The first thing is the auto deployment. The creation of the databases with replication is completely automated. You get to specify your topology with declarative syntax, and then the system automatically creates a sharded database. And then once the database is created, you have multiple methods. You could say my sharding method is system managed. In that case, we use consistent hashing algorithm. You could also say composite. You can have set of shards for one geo and a set of shards for another, but within each geos, you would have a uniform data distribution. That's composite. Centralized schema maintenance. basically, although you have many shards, you don't go to each and every shard and inject your create sharded DDLs, etc. You go to a central location called the catalog, and then that's where you execute your DDLs. And then shard directors will make sure that those DDLs are applied on all the shards. The two kinds of routing. So far we talked about data distribution as well as the database creation as well as the schema creation. Right now, once the schema is created, now how do I access my shards? Right? How do I get to the right shard for my key? As I said, there are two ways. One is direct routing, wherein you pass a key and then the system makes sure that you get routed to the right shard. And then once connected, the scope of your transaction is that shard, and then you execute the transaction within the scope of that shard and you exit out. You basically check in the connection. Proxy routing is when you don't know the key, sharding key, or when you want to access data from multiple shards for reporting needs, etc. Then you would do proxy routing. For that, you would go connect to the catalog database and execute your SQLs unchanged. And the catalog, which is also known as a coordinator, will parse a SQL and pushes the SQLs down to the shards, and queries get executed at the shard level, and the data is brought back and sent to the client. That's proxy routing. And then a few other advantages. Online scale out. If you want to add more shards or remove shards, you can do that online. And there is complete support for the lifecycle of a shard database, whether it's compression, security, enterprise manager, etc. Okay. Now I'll quickly go over the high availability configuration, and then I'll go into the developer aspects of it, which is the data modeling as well as the APIs. So from high availability perspective, you have two options. Or for that matter, three. The first one is data guard, wherein you would have fast start failover configured for a given shard and its replica. Right? If a shard goes down, you automatically fail over to its replica. And you can also say Golden Gate. In this example, I have 3 shards. I'm using Golden Gate. Automatically, you get multi-master deployed for you. And then you can see that a chunk of data is replicated to another shard. So if a shard goes down, the chunks are available on other shards, and you get access to your data that way. Okay, that's with Golden Gate. And then some customers use rack at the shard level, and we support that as well. So this is for node availability, right? If at a shard level, for example, if you have 2 node rack cluster, if a node goes down, your shard is still available accessing the other node. Okay. So now let me skip the creation of the sharded database and go to the data modeling considerations. The important thing, I took an example here, a customer's table family. There's a customer's root table, orders, a child, and the line items is a grandchild table, and there's a products table, right? The important thing to consider is for you to be successful with sharding, you want to have a structure which looks like this, that is equipartitionable. So a set of customers, their orders, line items that are equipartitionable, so that related data is placed in a given chunk and relocated as needed when shards are added or removed. Okay. And then at the design time, the sharding method, whether it's system managed or composite sharding, or in 18C, the user defined sharding with list or range, that must be defined, and then sharding key must be established by the application. Okay, and the sharding key must be the leading column of the primary key. That's a key requirement as well. And then what about the tables that cannot be sharded? We call that as duplicated tables. These are lookup tables, right? And we allow you to create those as well, and we make sure that those tables are replicated to all the shards as well. So the essence is, if you join customers, orders, line items with products, for a given key, you would only go to one shard and execute your transactions. Okay, let me explain those details here. I take the same example, customers, orders, and line items. And when I shard them, I make sure that a set of customers, their orders, and line items are placed in one and only one shard. In this example, Mary, her orders and line items are in shard 1. Likewise, John, his orders and line items are shard 2, so on and so forth. I'm showing one example, one row, but it's not limited to one row. You could have billions of rows in that partition. And what about my products table? In this case, this is my reference table. We allow you to duplicate this data on all the shards using read-only materialized views. So once you connect to this shard, let's say Mary logs in, she gets connected to the shard 1, and all her transactions can be executed by accessing these tables that are residing on shard 1. Okay. Here is one concept that you want to be familiar with. Chunk is nothing but a table space which contains partitions of related tables. In this case, partition P1 of customers, partition P1 of orders, partition P1 of line items. These 3 partitions are placed on a table space, right? And that table space is called a chunk. And a chunk can also be a group of table spaces if each of these partitions are hosted on separate table spaces. Okay, and this chunk is our unit of data movement. When you add shards or remove shards, we relocate and rebalance data, and we rebalance at the unit of chunk. Okay, all right. So here is one example of creating a tablespace set as part of creating your sharded tables, right? So when you create a sharded table, you want to, there is one prerequisite you want to do, which is create your table spaces across a pool of shards so you can map your partitions to these table spaces. So in this example, I have 3 shards, shard 1, shard 2, shard 3. The default number of table spaces when you do a create table space set is 120 per shard, right? So you have 120 table spaces in shard 1, 120 in shard 2, 120 in shard 3. Okay. So now when you say create table space set, we create all these table spaces. In this example, 360 table spaces. Okay. 120 on each of them. So once I do the table spaces creation, I create my sharded table. The syntax is very similar to what you've been doing when you did create partition table, right? Your columns data type, you specify your sharding scheme, in this case, consistent hashing, and what is the sharding key, and what's the table space set that you want to create your partitions on, right? So when you do this, you have 360 table spaces that you already created as part of a create table space set. Now you say partitions auto. That means you're creating 360 partitions and mapping each partition to a table space. That's for your root table. Your child table is created exactly like how you did the root, except for now this time around you say partition by reference. You're doing equipartitioning. So if you have 360 partitions here, you'll have 360 partitions on the orders table, and that's how we know what are the related partitions that need to go to a given chunk, right? Orders P1 and customers P1 will go to chunk 1. Orders P2, customers P2 will go to chunk 2, so on and so forth. The duplicated table is created with this syntax called create duplicated table. When we do this on the catalog, the master table is created on the catalog, and that's where you load the data, and the read-only materialized views will make sure that every 30 seconds the data is synchronized across all the shards. Okay. So now let me go into the routing from the developer perspective. Before that, let me check on the chat to see if there are any questions. Okay. Perfect. We'll touch upon these questions towards the end of the session. All right. So as I mentioned, we've enhanced Oracle integrated connections pools, whether it's UCP, OCI, ODP.NET, etc., in support of sharding. So this is an example that I'm showing that's for UCP. So how do I specify a key so that I get connected to the right shard? I'll use 2 calls, 2 APIs. One is a create sharding key builder, with which I build my key. In this case, my key is Mary.Smith and her email. And then I check out a connection from the connection pool using the create connection builder. So these are the 2 calls that I would make to get connected to a shard for this particular key, right? So that's a change that you would do from the application side. So now how routing happens, right? So you pass the key to the connection pool, and when you initialize the pool, you go to the shard directors, and the shard directors will understand the topology map, and based on the key, they'll let you redirect to the right shard, in this case, the shard in red, and you get connected. So the very first connection to the shard as part of the pool initialization, the connection pools are smart enough to understand and extract the topology, the chunk layout of what are the chunks, what are the ranges of sharding keys that are mapped to the chunk on this particular shard, and that metadata is brought into the connection pool. And we do like that for every first connection to each of the shards. So over a period of time, we establish a data structure that looks like this. Here are my chunks. Here is the range of sharding keys that are mapped to the chunk. And here are the shards that are hosting these chunks, right? And that information is kept up to date in the connection pool metadata, in the connection pool's cache. So that subsequent requests will go directly to the shards based on the key that you provide, completely bypassing the shard directors, right? That's how we're very fast and scalable. So bottom line is you use your API calls that I showed, you pass the key, and you get routed to the right shard at the connection runtime. Okay. The next one is proxy routing, wherein if you cannot pass a key, or if you need to go access multiple shards to do some basic reporting, etc., then you would connect to the coordinator, which is nothing but the catalog. Coordinator reads the SQL, rewrites the query, and to do most of the processing on the shard level, right? And then the data is executed. Basically, the queries are executed at the shard level. Data is brought back to the catalog. And if there's any ordering or sorting that needs to happen, it will happen one last time at the coordinator level, and the data is sent back to the client. Okay, and this is proxy routing. And as you can easily observe, that direct routing is what you want for fast and scalable performance. Proxy routing is targeted for basic queries, reporting and analytics, etc. Okay, how do I do DMLs on a shard table? You could do DMLs as long as they affect only one shard. For example, in this case, update S1 set column, and you specify where sharding key equals some constant. So you know you're going to go only make this change happen on one and only one shard, right? Those kind of DDLs are supported. If you're within a transaction, you could also have multiple single shard DMLs. Like for example, in this case, I could insert into one shard, update another, delete another, but I could still commit using a distributed transaction with a two-phase commit, right? And we support that as well. Last slide on the lifecycle of a sharded database. As a DBA, you can explicitly move a chunk from one shard to the other, or you can split a chunk if it's too big. And you can, as I said, you can add shard and remove shard online. Whatever configuration changes you're making, we automatically publish the updated topology map to the connection pools using fast application notification via ONS, right? So the connection pools automatically know this information and update the topology map. And backups wise, all the max availability best practices are supported. That's for backups and recovery. You could patch your shards from one central location using OPatch Auto. You could use Enterprise Manager and SQL Developer to manage and monitor your sharded database. All right, so I'll stop here, and then I'll switch to the chat window to see what questions you have thus far, and then we can go from there. Okay. Okay, Judith says, does this mean that all the tables in the sharded database should share the same sharding key except the duplicated tables? Yes, that is correct. So in this release, we support a single table family. That means you're sharding all your tables based on a particular key. In this example that I showed, customer ID is your key, right? So, and then in the future, what's on the roadmap is ability to have multiple sharding keys in a given sharded database as well. Okay. So is this DDL executed on the shard catalog? Absolutely, Judith. So what you do is for your create sharded table, create duplicated table, you connect to the catalog and execute your DDLs there. And these catalogs will capture these DDLs and store it in the dictionary internal table. And then we'll make sure that these DDLs are applied on all the shards. Okay. So that is correct what you said here. Okay. The next question is, how is a new key value created for the very first time? Can this happen on any of the shards? And if yes, then how is the duplication avoided across the entire sharded database? Very good question. How is a new key value created for the first time? So this is where you would do at the web tier or at a tier above your connection pool, right? So somehow the keys are created and then they passed to the connection pool. And then based on the key that you provided, we hash out and get connected to the right shard, which keeps this particular, which belongs to a given range. And then once you connected, that's when you can insert data, or you can update data, or you delete data, etc. Right? Bottom line is you do the key generation above the connection pool, and you pass the key, and you get routed to the right shard based on the hash of that key. Okay. The question that you have is, can this happen on any of the shards? And yes, how is the duplication avoided? As I said, we partition the data based on the consistent hashing. So we make sure that this particular key is only read-writable or writable only on one and only one chunk, or one shard for that matter, right? So let's say you got hash for a given key, you got hash to shard 1. You can be rest assured that that particular range doesn't exist on the other shard for you to write for that matter. But in the case of Golden Gate, you do have the opportunity to be able to do read-write on multiples. And in that scenario, what we'll do is we'll master that particular chunk so that you're always writing to one chunk and avoiding the conflicts on that note. Okay, so there's one more question. Judith says, does this mean that even for a new key, the value of the key should already be passed in while connecting? That is correct. Even for the new customer ID for that matter, that needs to be passed. The value of the key has to be passed, and then internally we'll hash it out and let you connect to the right shard that is hosting this particular sharding key. So if there are no questions, there is one thing that I would definitely want to bring it up to your notice, is the information that you may want to access. For example, for other resources, we strongly recommend you to go to this OTN sharding portal, oracle.com, go to Oracle Sharding. This is a good place where we keep all the collateral, whether it's webcasts, white papers, customer reference stories, or even for that matter, cookbooks and documentation. It's all kept in the OTN sharding portal. Strongly urge you to take a look at that. We do have blog posts that we write that you may want to take a look at, nageshpatel.com, as well as follows on Twitter for any up-to-date information on sharding. Okay. Okay. All right. Looks like all the questions that Judith has, we have answered. So given that, like I said, if you have any question, you have my contact information. Please do let us know. We can be of any help. We definitely will be glad to help you. All right. Thank you very much. Thanks, Nick.